Example 42. A 0.5 kilogram block slides on a horizontal track. The first part, A to B, is frictionless. The second part, B to C, is rough, and the block eventually compresses a spring. We want the total distance the block moves before it comes completely to rest. Let's draw the setup. We have a horizontal track. Point A to B is smooth, and B to C is rough. A spring sits from C to D with length 1 meter. The block starts at A with an initial speed of 3 meters per second. Let's list the key numbers. Mass is 0.5 kilograms. The coefficient of kinetic friction is 0.2. The coefficient of static friction is 0.22. The spring constant is 2 newtons per meter. The distance A to B is 2 meters, and B to D is 2.14 meters. Now, let's use energy. Initially, the block has kinetic energy 1/2 mv squared. That gives 2.25 joules. On the rough section, friction does negative work. The friction force equals mu k times mg. That gives 1 newton over the distance B to D, which is 2.14 meters. The work done by friction is 2.14 joules. So only 0.11 joules are left to compress the spring. Let x be the compression of the spring. The leftover energy equals friction over distance x plus the spring energy. That gives the equation x squared plus x minus 0.11 equals 0. Solving gives x equals 0.1 meters. That's 10 centimeters. Now, we check if the spring pushes the block back. The spring force is kx, which is 0.2 newtons. The maximum static friction is mu smg, which is 1.1 newtons. Since the spring force is smaller, the block stays at rest. So the total distance traveled is A to B plus B to D plus x, which is 4.24 meters. Final answer. The block travels 4.24 meters before it comes to rest.